Assalamualaikum and good day everyone. We are going to continue our discussion with capacitance. Why capacitance is relevant to the topic that we discuss now? This is because a capacitor consists of conductor, dielectric and electric field. Here I want to tell you that the capacitance in EMT is not same to the capacitance that we learn in circuit theory. Okay, where in EMT we are considering a condition, while in circuit theory we are talking about the device itself. Okay, so I'm going to show you how it make a difference. Okay, let's say we have this material or area, and I'm going to label this one as conductor number 1 and this as my conductor number 2, and between this conductor 1 and conductor 2 I have a dielectric. Okay, now when we have this kind of condition where it is if a conductor and dielectric at the same time, we can call this condition as a capacitance. Okay, this is what I mentioned previously. In reality, this application can be found in power distribution. Okay, let's say this is a tower, and here we have the transmission line. Okay, and this is the second transmission line. Okay, and let's consider this transmission line is using a conductor. So now we have one conductor here and a second conductor here, and dielectric is between this conductor and this conductor, and this condition we call it a capacitance. And this kind of a situation that we are going to consider in EMT. So back to this diagram. Okay, we are going to continue our analysis using this diagram. Okay, as we know that the formula for the capacitance is C equal to Q over V. So this is the equation for the capacitance. Okay, now how we are going to relate this Q and V with this diagram. So let's say I have my positive Q at my first conductor. So this is my positive Q, and this will be my negative Q at the second conductor. Okay, the summation of Q should equal to 0. Thus, the magnitude of this Q and this Q is same. Okay, when we have the Q here, still remember what happened when we have conductor and dielectric? Yes, we are going to introduce a surface charge. Okay, now I'm going to draw my positive surface charge at this surface. And I'm going to label this as rho S, while the negative surface charge is at my second conductor here, and I'm going to label this as negative rho S. When we have two different surface charge here, what will happen? Yes, we have E field coming out from the C1 and into the C2. So this is the E that introduced by this situation. Okay, so another E here, and we know that we can have E in this direction as well. So now we have the E here, and we can relate this E with this V. Okay, now I'm going to write, I think you know this equation, okay, where V is equal to negative integration of E dot dl. While the limit here is from the conductor to surface to the conductor 1 surface. Okay, why I use this limit? Because I want at the end I will get the positive value of V. In my previous video, I discussed how I can get the formula for the resistance using field theory. In this video, we are going to use field theory to calculate the capacitance as well. Okay, to do that, we need to select our Q. Okay, we need to choose either this conductor or this conductor. In my case, I'm going to choose this one. Okay, so from here, I'm going to write equation of Q. This one is equal to the integration of dq equal to the integration of rho s ds. Okay. Recall our boundary condition, conductor dielectric, where from that condition, we know that we can write D equal to rho S AN. Okay, and here I'm going to write rho S equal to D dot AN. How I get this one? It is actually I'm replacing this one into this one. Then you will get the rho S. So let's check. If I replace this one into this one, I can write rho S AN dot AN. And this is equivalent to 1. So I will get only rho S. That's why we can use this equation. Rho S equal to D dot AN. So we get a new equation here where Q equal to the integration of D dot dN. AN. AN ds. And here I can substitute with ds vector. Then I can write the final equation Q equal to D dot ds. So this is our final equation of Q. In the previous slide, we get Q equal to the integration of D dot ds. And we know that C equal to Q over V. And this V is equal to E negative integration E dot dl. So we replace this into this Q and this one to V, then we will get this equation. C equal to the integration of epsilon E, because we know that D equal to epsilon E dot ds over negative integration of E dot dl. And this is our equation for capacitance. And we are going to use this equation in this subject. So that's all for this video. Thank you.